Oh, that's right. We don't get a voice because I have my computer muted. All right. Okay, so our guest today is Dr. John Anderson, and he's a department head at Dunwoody campus, UPC Dunwoody campus. And he's going to talk to us today about the impact on water quality of the high-density septic systems in Gwinnett County. I typed it a lot, so I can say it in one sentence. We just do this to be timely because we've had lots of rain going on, and the creeks are really high, and people might think, hey, get warmer, let's go out into the creek. But before we do that, we should listen to Dr. Anderson's talk. So let's give him a warm welcome. And
thank you. Just to give credit to my my advisor, this work I did for a second master's degree at Georgia State for a degree in geography. So Dr. Lawrence Kiagi was my advisor at Georgia State. Just to give us a setting as to where Gwinnett County is, it's one of the metropolitan counties in pink here. Gwinnett County is to the north and east of downtown Atlanta. Gwinnett County has, in the 1970s through the mid-1990s, was the fastest growing county in the United States. And so, as you can see from these Landsat images, the red on the Landsat are vegetation, mainly trees. So in 1988, you can compare to 2009, and you can see there's a lot more red in 1998, where in 2009 there's a lot more blue, which is urban regions, paved areas and all. The county's expansion plan in the early 70s, it was still considered a rural county, and so as residential property was being developed, being classified as a rural area, they didn't have the infrastructure for sanitation, and so the homes built between 1970 and 1993, the majority of them were put on a septic system. Looking at the county, in 1988 and 2009, the amount of water in the county, that would be ponds and lakes, hasn't changed. Urban, by classification of those early Landsat images, in 1988, there was 25% of the county was urban, where in 2009, it had increased to 42% of the county was urban. Forests decreased, as well as the grassy areas. This number, the decrease of grass, a lot of it is that the forests, some of the forested area of today used to be grassy areas in the past. So it's not that we've actually decreased the amount of grass, it's that urban areas have increased, losing trees, some of the grassy areas, and then some of the older subdivisions have matured, people have grown trees, and so there's more trees in some of the areas. One of the aspects of my project was to map what properties had a septic system, because the county did not have a map of which properties were on septic systems and which properties were on the sewer system. And I was working with a piece of software called Geographical Information Systems, which has various capabilities of taking information in layers, and then you can analyze the layers to produce new information, so to speak. So I had available to me where the sewer lines ran in the county. And so the assumption is if there's a sewer line running down the middle of the road, the properties in and around that sewer would be on the sewage system. And so I could set a buffer in and around, that's what this little blue area of about 75 feet from the sewer line, and that would encounter the properties that were on sewers. Then I could capture that to where then all these blue areas would be the residential areas and properties that were on sewers. And so those areas that were residential properties that weren't within that sewer area would then be on septic. And so in this map, these lighter pink colored areas are the properties that are on septic systems. It's not a exact representation in that in boring down into the information, cemeteries don't have sewers running to them. They're not residential, but they were classified as septic. So my map isn't perfect. I'm still trying to work with the county, Gwinnett County, to see if I can get water records. Because people who are on a septic system only pay for water, where those people who are on a sewer system, they pay for water and they pay for sewage. And how they determine it is the amount of water you use. They charge you that same amount of quantity. That the assumption is the water in is the water out, either going through your faucet into your sink, from the water into your commode. So if you water your lawn a lot, you're paying for high-priced water because you're actually paying for that water twice, and it's not going into the sewer line. So ultimately, what I was able to determine is the areas that were on sewer are in orange, and the pink areas are those areas on septic system. And this little blue dot there is my house. My house has a septic system, so that was one of the impetus of me doing the research. So looking at the information, what I was able to determine was by the number of properties, 68% of the county is on sewer. Sounds pretty good. 32% of the county is on septic. So it doesn't seem like there's very many septic systems in the county by sheer number of property. If you look by area, though, sewers only make up 55% of the county, and 45% of the county by acreage are served by septic systems. Total number of septic systems, you count up the number of properties, and again, this number does include some cemeteries. So the total number of septic systems is about 85,000 septic systems in the county, which is an average of 487 septic systems per square mile. Well, the Environmental Protection Agency set the definition of a high-density septic system area as 40 septic systems per square mile. What that means is at 487, that's 10 times what EPA says is high-density septic system. So we could actually call it extreme density septic systems in Gwinnett County. The state of Georgia has an ordinance that trying to reduce the number of septic systems in areas that as the sewer system is expanded, the state ordinance says that if a property is within 200 feet of a sewer line, they are to be connected to the sewer line. Somewhat has a snowball effect, is that if you bring the sewer 200 feet, that means people that were more than 200 feet are now closer to the sewer, and so there's a little issue there of if you keep expanding your sewers, ultimately everybody would be on the sewer by that ordinance. And so there are a certain amount of allowances to that. So that's why a lot of the septic systems haven't been. But if we took that rule of just simply those properties within 200 feet of a sewer line, it would reduce the number of septic systems by 29,000 septic systems in the county. Again, as you can see, they are in blue here. Those are the areas that the septic systems would be removed if we went by the state ordinance. So you would think if you remove those put them on the sewers, the number of septic systems per square mile would decrease. But in actuality, when you do the mathematics, it works out that it would increase the number of septic systems per square mile to 625. It's a factor of, if you look, there's a large number of areas here. These are very large properties. Some of these properties are almost 2,000 acres. And so you take that out, because again, it's per square mile, you're reducing the area that, and so it offsets it and increases the number of septic systems per square mile. That's for the entire county. It would reduce that the sewers would be serviced by number, that 79% of the properties would be on sewer and only 21%, so it would decrease by 10% the number of septic systems in the county. So what I wanted to look at, being a geologist as well as a homeowner, and I run in the morning, and on rainy days I would smell up come a bubbling crude, to coin the phrase of a television show which had nothing to do about septic systems. But nonetheless, looking at that, now and then I would get an odor of septic effluent. And then it would disappear when the rains would stop. So I thought my hypothesis was high rainfall will allow the septic effluent to be flushed to the surface. Well, I did literature research on this project, and I found that as a septic system gets older, because the soil is what's cleaning up that septic effluent, and it's bacteria that is actually helping to clean up the water, you get biofilms in the soil. And you get small little conduits, the water flowing through the soil, you get various conduits that are lined with this biofilm. And the biofilm is the bacteria pulling it out, but in actuality, the soil helps. Clay in the soil helps to lock on to various minerals, various bacteria as well. And so that biofilm actually acts like a pipe. And so the effluent in the center of that pipe is not being cleaned up. excuse me. And so the older the septic system, and researchers have found that some septic systems that are about 20 years old, the septic effluent has been monitored to be untreated, so to speak, for a half mile away from the septic system. So the literature says, yes, septic effluent can come to the surface in various regions. So I looked at two major stream systems. The United States Geological Survey does water monitoring on streams, numerous streams in the nation. So in Gwinnett County, I chose the Yellow River Basin, which is the largest river basin in the county, and then the Alcovy River Basin, which the Yellow River Basin has waste treatment plants. And so one of the explanations for why there was bacteria in the water was not from septic systems, but was from the waste treatment plants. They treat the water, but they don't get rid of all the bacteria. So that's the the explanation was that in the Yellow River, the bacterial count was based on the waste treatment plant. So I chose the Alcovy because it had no waste treatment plants. So all the bacteria there could not be claimed to be from waste treatment plants. And it was a river basin that had very little to no agriculture, so they couldn't claim that dogs or cows or pigs were adding the bacteria to the water from surface runoff. So even though the Alcovy River Basin is smaller in area, I chose subbasins that were equivalent in size as well as somewhat similar in the number of septic systems. So looking at it in the Yellow River Basin, Y1 is up here, almost a 10 square mile area. And interesting enough, it has a very high septic system, 2,000 septic systems within that drainage basin. Y2 here, a little smaller than Y1, much fewer septic systems. Then Y3 is the sum total of Y1, Y2, as well as all these other areas. So much larger area, 132 square miles, with 27,000 septic systems. And then Y4 is where the Yellow River exits the county, and it's at the monitoring station is the horse park that's close to Conyers along the Yellow River. The Alcovy, again, smaller drainage basins, but again, similar in percentage. So if we look over here, percentage, the Y1 has 37% of that area with septic systems. A1 has 30% with septic systems. So I tried to compare apples to apples, and so found areas, even though they were smaller, percentage-wise, they were very similar in the number of septic systems in that area. So as you can see, 15 to 12, 17. Again, these are more sub. Y3 is the sum total, so they're percentages. But ultimately, the exit point, the farthest downstream, 30% and 31% area by area having septic systems. So the United States Geological Survey measures a host, something like 380 different measurements to the water. I looked at all of them and then limited them to those that statistically showed significant increases or decreases based on the amount of rainfall and all. So I looked at water temperature, specific conductivity, the hydrogen ion concentration, which is very much related to pH, dissolved oxygen, the biochemical oxygen demand, and then various nitrogen compounds are measured in the water, and then a host of metals, phosphorus, and then the nasty stuff, the coliform, both total coliform, fecal coliform, and E. coli. E. coli is the bacteria that is the dominant bacteria in your digestive system in all mammals, as well as birds. Rainfall data, I collected data going all the way back into the early 1900s, because some of the water quality data went back into the 40s. And so I wanted to see, was there any relationship in a long period of time? And so I had specifically which day did it rain, how much rainfall, and so I tabulated and compiled, and so I determined the total amount of rainfall 7 days prior to when the water quality was measured, 14 days, 21 days, 28 days, thus the amount of rainfall in 1 week, 2 weeks, 3 weeks, 4 weeks, to see was there any increase. If you had, like we've had for the last couple of weeks, we've had a lot of rain over the last 2 weeks. Did that make any factor versus a rain that was very heavy, all one rain, and we got 3 inches in 1 day versus if we had a quarter of an inch for 12 days? Did that make a difference? A soaking in rain. And so there's a host of other measurements, as you can see. And so ultimately, I wanted to see, was there a relationship between total rainfall and the amount of fecal coliform? So as rainfall increased, was there a relationship with, as rainfall increased, did the coliform increase? Thus, giving an indication that you're flushing the flushing, so to speak. Flushing your septic effluent to the surface. And so as you can see, even though there's not a lot of points out here in the hinterlands here, statistically, it's fairly significant. At least you can get a best fit line that is a linear, that as rainfall increases, coliform increases. Again, I used various measures of the amount of rainfall. One of them I called a slug, which was, did you get a large amount of water in a short period of time in and around when the water quality was measured? And was there any relationship? And so as you can see, as you get an increase in that slug of water infiltrating the ground, you get an increase of coliform. Both in the Yellow River Basin in 1999 and Alcovy. So I tried to compare similar time frameworks as well. Various biological components, the nitrogen, the ammonia, phosphorus, which all have their origin from biological means. They could be from plants, they could be from animals. So again, it's not totally conclusive that it's all coming from septic systems, because some of these measures could be coming from surface water Because again, when you get rain, water flows over the surface and eventually ends up in a stream. So there's going to be a mixture of surface and then water that has traveled through the ground and is brought to the surface, which is the natural groundwater flow. But looking at ammonia, there is a positive correlation in both of those basins. Phosphorus, there's a positive correlation as increase of coliform, there's an increase in phosphorus. The dissolved oxygen, there's a decrease. As coliform increases, there is a decrease in oxygen, which should happen. That if you're adding bacteria into the water, it sucks up the oxygen, and so the amount of oxygen, dissolved oxygen in the water will decrease. So as you increase the biological component in the water, the oxygen demand is there, and so dissolved oxygen decreases. And so the biochemical oxygen demand is another measure, and so as coliform increases, the demand for oxygen increases as that bacteria is sucking up the oxygen out of the water. pH, as coliform is increasing, the pH is decreasing. A decrease in pH. How many of you have had chemistry? pH tells us what? A low pH is acidic. So decrease of pH means our water is becoming more acidic. And that is a case of with organisms dying and degrading, they produce acids, and so the pH declines. The hydrogen ion concentration, you increase hydrogen ion concentration, you decrease pH, because in actuality it's an inverse log. And so the lower numbers have higher hydrogen concentration. So again, this just shows a lovely trend that you decrease in pH, but you're increasing in the hydrogen ion concentration. And then specific conductivity is how much does the water conduct an electrical current? So again, with increased coliform, there's less conductivity. So, go jump in the water now and you can't be electrocuted as easily because of the conductivity. But it is a measure of the amount of material floating in the water that breaks up the conductivity of the water from passing a current through it. So there was this positive correlation to increased rainfall, increased coliform. Increased coliform was paralleled with the increases of various biological components to give evidence that some of this was coming from a biological source, and with so many septic systems, we could possibly say that the septic systems were the major source. But it's not conclusive. It just leads, our hypothesis appears to be being proven, but again, we would have to do more research. So I looked at, again, when you have biological material, the temperature, there was an increase in temperature of the water when there were higher fecal coliform counts. So I looked time-wise, time is on this, and so this is the water temperature over a span of time. And so as we can see, the water temperature increased and then decreased. And this is the fecal coliform graphed to time, and there were these lovely peaks of coliform at the same time that there were an increase in water temperature. Which again, bacteria live, they generate warmth, and so there's a relationship there. So then later on I will have a slide that will show water temperature, fecal coliform, and rainfall to show that. But looking at the metals, there are some metals, lead, copper, chromium, and zinc. Those are metals that are found in the rocks, but they also can have a source from car parts. So as you're running your car, lead is part of the paint in your car, so as it degrades, lead could be washed into the stream. Copper and chromium come from your brake pads. And so again, these measures of the increase of these metals as the coliform is increasing doesn't mean that it's being flushed from septic systems, because there's also a relationship of coliform increases as the rainfall increases, which also could be washing these metals into the stream. But magnesium, iron are very common elements in the rocks in Georgia. You know, the red clay of Georgia is iron. And so as we see that there's an increase of iron as we're increasing coliform. And just to show, here is rainfall. And so as we're increasing rainfall, we're also increasing the amount of iron. Iron could come from rusted cars, and so some of the iron could be superficial, but there's a lot more that we find coming from groundwater. And most studies have showed that iron is leached from the soil into the surface water. And oftentimes, well water has an iron taste to it because it's the leaching of the iron out of the rocks in the area. So, manganese and magnesium also are common elements that are in the rock. So if the rocks are leaching these elements, the bacteria could be also, as well as the increase of water, could be flushing the system. Now comes the spaghetti graphs, as I like to call them. They kind of, this one kind of, what does it tell us? Blue is the water temperature. The green is the 7-day total rainfall, and then the red is the coliform. So if we look at this portion of this upper graph, expanded out a little, as you can see, as we increase the the blue is water temperature. So as we increase the water temperature, we're increasing the coliform. The 7-day rainfall, we have this peak here, and then we get a peak of the coliform and the water temperature, which could be explained. You get a heavy rainfall. It takes time for the rain to infiltrate, push through the soil, and then come out into the streams and be monitored. So again, time is our x-axis here. So over time, we get this slug of water, and then we get this increase in temperature and coliform. We get another slug of water, and this is where things fell apart. High coliform, but low temperatures. So again, this is April. Again, spring. We've come out of the winter, and so water temperatures tend to be cooler in the spring. So this just may mean that the temperature is not totally coming from the degradation of the bacteria. Again, here we have an increase of water temperature, but a decrease in the coliform, even though we've had an increase in rainfall. So that it's not totally conclusive that there is this relationship of a slug of water bringing. And so the question of, is it runoff or is it flushing? This would say, yeah, it's being flushed. Here and here, it's not as conclusive. So possibly time of year and seasonality may be factors. Another theme for another day, so to speak, of research. So this graph shows the time. I have water data from the late 1960s all the way up to 2010. And so as you can see, the highest fecal coliform counts, and these are annual mean fecal coliform. So you take all the fecal coliform counts for that year, you average them up. So that would be the total, the average fecal coliform for that year. So the highest years of fecal coliform were back in the 70s, and it's decreased over time. Well, in the 70s, the county was more agricultural, and so a lot of the fecal coliform, especially in the Yellow River, the largest basin, that northern section of Y3, well, actually Y3 is that midsection, but it's the majority of the drainage basin, that there was a lot of agricultural areas. And with time, with urbanization, and especially in 1973, well, actually 1993 is when the bulk of sewage systems came into existence. But if we look at the amount of rainfall versus the fecal coliform, we also had, back here in the 70s, we had higher rainfall, average rainfall for those years than what we have had since. So we've had much wetter years in the 70s than what we saw in the 80s, except for here in the mid-1980s, there were a few years that were much more wetter. But if you notice, again, high rainfall, high average fecal coliform. High rainfall, high fecal coliform. We have another blip, another blip. High rainfall, another blip, but then we have a blip here of a fairly stable amount of rainfall. We have a blip in here, but it's not reflected. And again, these are annual averages for that drainage basin. So again, we're averaging. So again, if we go back geographically, we have these upper basins here that are smaller basins. This one has the highest concentration of septic systems, with close to 2,000 septic systems for this area. And as we go further down, this location here is getting all the water from this whole area for the Yellow River, where this collecting site only is getting the water from this area as well as this for this area. So you would think these smaller areas would have less water flowing into them, so there would be less effect of the flushing system, and so you would have lower fecal coliform. So let's see, does it work? Well, looking at the average for the entire year, 1999 was a year that I had water data from all 4 collecting localities for these 2 drainage basins. And so you would think smaller basins would have low numbers, and as you got further down, you would increase. So if we look at the Alcovy, we have A1, which is way up here, the more northern. It has a low average fecal coliform. As we go to A2 is not on the graph, but A3 has much larger area, higher fecal coliform. A4, which is the most southern of our drainage for the Alcovy, has an even higher. So as you increase the amount of water, you increase the amount of fecal coliform. That shows. Well, then for the Yellow River, we have Y1 up here, which again has the largest number of septic systems, has a higher density septic system, number of septic systems. And what we find is Y1 has about the same total coliform count as Y4, which is down here. And so there again, the perspective would be this should be lower than here, and this should be the highest. But we do find that for Y2 to Y3, Y3 has a higher fecal coliform than Y2, and it's just this Y1, which I didn't know when I was picking my water quality sites as to how many septic systems they were. I was looking at further upstream should have less water and less influence, but then when we look at the total number of septic systems in that area, there was a higher concentration, which now leads to maybe it is the septic systems that are adding to the water. Just some interesting things. In the last few years, we've had drought, and so less rainfall. This is fecal coliform. As we have a drought, we have a decrease in the fecal coliform in both basins, the Alcovy and the Yellow River Basin. Less rainfall, less fecal coliform average for the year, which again would lead to the conclusion that the coliform is coming from the septic systems. No rainfall, you're not flushing the coliform to the surface. So, let's summarize what we've seen in the graphs and everything, and the conclusions that we can draw. That there is a positive correlation between the amount of rainfall and the water quality. Water quality decreases with increased rainfall. That we get an increase of fecal coliform as we increase the discharge of our stream. The higher that I didn't show that graph, but again, with higher rainfall, there's more water in the stream. And so there is a positive correlation to the coliform and the amount of water within the stream. there is a positive correlation between fecal coliform and water temperature. That there is evidence that flushing of septic systems is occurring, which is causing higher fecal coliform in the water temperature, the rainfall, plus iron, magnesium, and other positive correlations which give an indication that we're flushing. And then the classic relationship of higher fecal coliform, increased biochemical oxygen demand, and a decrease in the dissolved oxygen. You take environmental science, they will cite that as you increase bacteria in the water, the oxygen, dissolved oxygen decreases, and the BOD increases. So it was interesting to see what teaching and selling students actually panned out in the data that I looked at. You might say, so what? Why does it matter that we're flushing septic effluent in the solution to pollution dilution? Well, what we're finding is that if we're flushing something from a septic system, which there's actually body fluids, they pass through you to get into there, that we also are finding that viruses can exist in water outside of the body. Those proverbial, can you contract a disease from a dirty toilet seat, has actually been proven correct. There are people who have been infected with HIV that are virgins. As well as they're recognizing that in especially marine water, they have actually had viable HIV viruses in the ocean. And they've closed beaches in various regions of the country. So, flushing something, and in actuality, it's not during the summer months. It's actually in the springtime. Colder temperatures, viruses are more viable. So the colder temperature water, and we saw that we had low temperature water and high coliform in the spring. Now's the time that you don't want to go slogging through the water.
I have a question.
Yeah.
Well, one of my online students said her daughter was sick from playing outside in the puddle.
Yes.
So, is there a correlation with health records, like the HMOs or the local clinics? Do they see an uptick in people getting sick after these rain events?
I really don't know. I haven't looked at that, and I'm not sure. I would hope CDC would look at those type of things. I do know that, like for Katrina and Sandy, those large events where there's been flooding, that you find the water being, you don't want to be slogging through the water. So, but have we recognized that kids playing out in the water, in the puddles, in these high density areas? I don't think anybody's looked at that. And so that would be a study there. And again, those of you who might be more science oriented, knowing something that intrigues you, you have a master's thesis to go and investigate. And you might get money from CDC to do that. So again, always tuning your ear to, okay, these are things that an unanswered question. You one who answers the question. And we did see seasonal variations in the amount of fecal coliform in the water. So, I brought up several things that aren't even listed here, but looking at the age of septic systems to see is there any relationship to the older septic systems, areas that have older systems, is there more effluent being leached? That would be a very interesting study, and in the county there is the data. It gives when the home was built. And the assumption would be when the home was built is when the septic system was installed, and so that would be the age of the septic system. And the county does have the records that if a house was built in 70, but they had to put in a new septic system in 1990, the county would have that. And so putting those records to this would also help to make that research viable. The interesting of water temperature and fecal coliform would be a very interesting study to see, is it the coliform that is causing the increase of temperature of the water? As well as I would love to improve my map, get rid of the cemetery from it, and so get more data there. But ultimately, maybe the Yellow River is well named. People laughing. You are allowed to laugh at my very poor joke. So, is there any questions?
Actually, one of the online students has another question. She was wondering about snowfall. Of course, it's not really usually a problem around here, but
Right.
Occasionally, every 10 years, we have like a snowfall.
Right.
And so that also includes, the concentration of fecal matter and coliform.
Most likely only when the snow melts.
Yeah, so that's what she was asking.
Right. That if you have it laying on the ground and then it melts, typically snow melts slow enough that you get less runoff and more infiltration. And so that's where looking back at those times where we have had snowfall to see is there any relationship there. Georgia is probably not the best place to be looking at snowfall. But again, this should translate to areas in Colorado as they expand. A lot of the expansion in Colorado is in rural areas, and so the area had septic systems and they don't have the money to put in a waste treatment plant. I heard a study of the upper Etowah River Valley, which is the Etowah River flows in to make like Lake Allatoona north of Marietta and Kennesaw. And the northern part of the state of Georgia is expanding at a fairly rapid pace. Cherokee County, Forsyth County, those counties up in over here. And so they were studying the upper Etowah River Valley. They have waste treatment plants, and they were looking to see as that area expands, could they build more waste treatment plants for the homes to be on sewers. And what they found was the upper Etowah River Valley, the streams are at what is called total daily TMD, total maximum daily load. That the upper Etowah River Valley is right today is at its maximum amount of fecal coliform that could be added from a waste treatment plant. So the consultant's conclusion is no, Cherokee County could not build a new waste treatment plant, that all the new homes built in the upper Etowah River Valley should be on a septic system. And I was like, no! But ultimately what we need to do is get a handle on what is the load of a septic system onto a stream. Because the corollary to that study would be how many septic systems that are existent, if you removed them, would lower now the fecal coliform in the upper Etowah River to where you could build a waste treatment plant, which is far superior to the septic system. Because you clean up the water. And a lot of our newer waste treatment plants are what are classified as tertiary, or they clean the water 3 times. And Fulton County has a waste treatment plant that they don't let anybody try it, but in theory, the water coming out of the waste treatment plant is drinkable. I don't know if I would test it. Knowing where that water had been, but in theory, it is very clean. You know, everything is supposed to be dead. Where DeKalb County's waste treatment plant, there's still fecal coliform coming out of the plant because it's only a secondary treatment plant. They clean it once. They treat it for about 30 hours, and then it's put back into the South River. So those people in the Decatur campus, the South River is just south of our Decatur campus. Any other questions?
I just have one more quick one. So also moving to the next county. I mean, is the county government aware of this super high speed density? I mean, that is like 10 times higher than the EPA would think is reasonable. And are they trying to do anything about it?
They know about it. They are not per se doing anything about it, except in those areas where septic systems are failing. If there's a considerable number of failing septic systems, then that's when, and if they're in a 200, well actually they will force the homeowners to connect up to sewers. There's enough sewer lines running that a lot of the properties could be connected. But right now it's at the cost of the homeowner. I looked into the closest sewer is about 800 feet from my home. And the cost would be $8,000. And I would have to get 5 other people in my subdivision to connect up. Yeah. Not in the present economic. You would recoup about a quarter. Your property would increase about a quarter. But DeKalb County has septic systems. Fulton has far less. But South Fulton has more. But then as you get into the northern counties of Georgia, you're increasing in septic systems. That's the more prevalent. It's only in the urban areas. Well, what gets me is Norcross. Norcross, the city of Norcross, has septic systems. It's the suburbs of Norcross that are on the sewers. Norcross is an old city.
Are there any more questions? Well, nothing, let's thank our speaker.
All right.
And stay tuned after spring break. The first talkback will be another geology person from Dunwoody campus, Dr. Dion Stewart,
Oh.
and talk about colors, how to make gemstones change a different color.
Oh, okay.
It's not always all natural.
Rubies and spinels and how jewelers increase the color of the gemstone to make them look to be higher value than what they actually were.
And there's certainly lots more colorful jewelry out there these days than
Right.
when I was young.
I won't spoil it, but it is some rather interesting things. I've seen his talk.
All right. Well, thanks for coming out. And,
All right.
have a great spring break. Have to get food.
Yes.
What are you using to analyze this? Are you using Excel or it's kind of like R?
Yeah, I have the data in Excel. The statistics I was pulling into SPSS.